All right, quarter 4, week 2, day 4. Find the quotient. Keep, change, flip. Here we go. 10 over 11 times 9 over 8. Can we do any cross reducing? Yep, we can put 2 into 8 and get 4. We can put 2 into 10 and get 5. Is there any other cross reducing? No, doesn't look like it, but it saves us some time later. 9 times 5 is 45. 11 times 4 is 44. So we have 45 over 44. How many times does 44 go into 45 without going over? One time. And of course, one group of 44 will leave 1 left over, right? 45 minus 44 is 1 over 44. Okay, so that's quite an interesting fraction, but that's our answer. 1 and 1/44 is the answer, finding the quotient to this division problem. Maria's math test had 25 questions. She got 84% correct. Okay, that's not a bad grade, right? How many problems did she get wrong? Okay, so remember 84% is the same as 0.84, right? Because 84 100ths or 84 over 100. So we can take any of these and figure this out. All right, so in this situation, let's go ahead and do 84 over 100 times 25. 25. Just should be 25 with a 1 underneath it. Actually, let's just make it a 1. All right, so let's do that. So then we can see, can we do any cross reducing? Yep, 25 goes into 25 once. 25 goes into 10 4 times. Wow, this is interesting. Again, we can divide 4 into 4 and get 1, and 4 into 84 and get 21. So we're left with 21 over 1. So basically, 84% of 25 is 21, right? So that's how many questions Maria got correct. And what are they wanting us to find out? How many did she get wrong? Okay, so if there was 25 problems and she got 21 of them correct, we can just subtract that and realize she got how many of them wrong or incorrect. The answer is 4. Okay, so that's how many she got wrong. She missed 4 out of 25, and that gave her her 84%. Write an equivalent expression. So basically another expression that would end up being the exact same value. All right, so one thing that I noticed is that every single one of these numbers is even. And since they're all even, I know that there is a number that goes into every single even number, and that is the number 2. So what I'm going to do is I'm going to take the 2 and put it right there. And then I'm going to begin my parentheses. How many times does 2 go into 8? 2 goes into 8 4 times, so it's going to be 4y. Plus, how many times does 2 go into 12? 2 goes into 12 6 times. Right? And then how many times does 2 go into 2y? Well, 2 goes into 2 1 time, so that's just going to end up being y. And then how many times does 2 go into 8? 4 times, right? So there we go. There's an equivalent expression. Now, there's another way we could have done this, where we just simply combine like terms. We can look at the 8y and the 2y, right? And 8 plus 2 is what? 10. So we have 10y, right? And then we have 12 plus 8, which is 20. Okay, that's another one we could have done. So there's a couple of ways we could find an equivalent expression. Okay, we could actually simplify this one too and to divide 2 out of that, right? And then 2 goes into 10, 5y. And then 2 goes into 20, 10 times. So there's another one you could have done. As a matter of fact, we could have put 10 on the outside on each one of those. And then we would just have 10 on the outside and then y plus 2. So there's so many different ways we can do it, but there we go. There's a few examples. As long as you know why those are equivalent, that's what you want to do. Joycelyn is going to put wood floors down in her living room. The room is 24 feet long, so 24 feet long and 15 feet wide. So 15 feet wide. It says, how many square feet of wood does Joycelyn need? Well, remember the area of a rectangle is just base times height. So all you have to do is 24 times 15, and that gives you 360. So that's our answer, 360 feet squared. That's all she would need. Angie is wrapping a present for her best friend. The box is 16 inches long, 12 inches wide, and 3 inches high. So I guess 16 would be here. 16 inches long, 12 inches wide, and 3 inches high. All right, so how many square inches of wrapping paper? All right, so we're not doing volume, so we can't just do length times width times height, which would be awfully nice and convenient, but we can't do it that way. We have to find 6 different sides, right? Because we have a front and a back, side, top, and bottom. We have to add all of those sides up. Okay, so let's go ahead and start figuring out each side. Let's do the sides. We have 16 by 3, right? 16 times 3, and that's 48. I'm going to write it down twice. Why am I going to write it down twice? Okay, because there's this side and there's the opposite side over here, right? So we got those two so far. And then let's do the front and back. Well, this is 12 by 3. 12 times 3 is 36, right? We have to write that down twice. Why is that? Because that's the front and the back. All right, and then we have the top and the bottom. The top and the bottom are here. Oops, I thought I had a different color. Are here and down there. All right, so this is going to be 16 by 12. Okay, so 16 times 12 is 192. Going to write that down twice again because we have 2 of them, the top and the bottom. All right, so for the left side, we're just going to do 8 plus 8 plus 6 plus 6 plus 2 plus 2, and that equals 32. All right, so we'll put the 2 there, carry the 3. The next one, we have 9 plus 9 plus 3 plus 3 plus 4 plus 4 plus 3 again. And that's going to be 35. So we put a 3 here, a 5 here. 3 plus 1 is 5. All right, so we're going to need 552 inches squared. That's how much wrapping paper we're going to need to cover this box. 552 inches squared. All right, we have George bowled 5 games. He scored 131, 110, 128, 105, and 120. What is the mean of George's scores? Okay, so the mean means we're going to add them all up. 1, 2, 3, 4, 5 numbers. We're going to add them up and divide by 5. So I'm going to do 105 plus 110 plus 120 plus 128 plus 131, and that equals 594. 594. Okay, but to get the mean, we're going to have to divide it by 5, okay, and see what that answer is. So we have 594 divided by 5, and the answer is 118.8. So that is the mean. Okay, so we add up all the digits, add them all up, divide by 5, because that's how many are in the number, or in the data set, and we get 118.8 as the mean. Find the mean absolute deviation. The first thing we have to do is find the mean. So we're going to add 4 plus 5 plus 8 plus 8 plus 10, and that gives us 35. So if we add all these together, it's 35. How many numbers are in the data set? 1, 2, 3, 4, 5. So we're going to do 35 divided by 5, and that's going to be 7, right? So our mean is 7. So we're going to subtract that from all of the numbers in the data set. All right, so we have 10 minus 7, which is 3. 8 minus 7 is 1. 8 minus 7 is 1. 5 minus 7 is negative 2, but we're just going to keep it a regular 2. And then 4 minus 7 is negative 3, but it's just 3. So we have to add these up. We have 3 plus 3, which is 6, 7, 8, 9, 10. So the answer is 10. We have 5 numbers in the data set, so it's 10 divided by 5. 10 divided by 5 is 2. So that is our mean absolute deviation. All right, so 2 is our mean absolute deviation, which means from the mean, from the 7, it would be normal to be 2 higher than that or 2 lower than that. That's our mean absolute deviation. Place the number 5.7 on the number line. All right, so we're going between the number 5 and the number 6. And then we're breaking it down into tenths. Okay, so we have 5.1, 5.2, 5.3, 5.4, 5.5, 7, 5.8, 5.9. And the one we need to plot is 5.7. So that's all we have to do is put a dot right here where it says 5.7. Okay, that one's it. So between 5 and 6, you go to the 7th dash and put your dot right there. Okay, graph the ordered pair -5 and then -3. Okay, so on both occasions, we're going to go negative directions on this graph. So once again, you start right there at the origin. Okay, and you're going to go first -5. And you'll always do that on the x-axis, on this one here. Okay, so we're going to go -5, starting at 0, 1, 2, 3, 4, 5. So we're just right there at the -5. And then we go -3. So do we go up or do we go down? Okay, we go down because -3, you can see right here, these are the negative numbers. So we're at -5, we go down 1, 2, 3. That puts us right here. All right, and then it's going to tell us to reflect over the y-axis. Okay, so we're still going to reflect over the y-axis. It could tell us to reflect over the x-axis, but we're using the y-axis as our mirror. So you need to go the same distance from the dot to the y-axis. So we have 1, 2, 3, 4, 5 places. So there's going to be 1, 2, 3, 4, 5 places. So our graph on the other side would be right there. All right, so we did graph the -5 and -3, and that put us right there. And then we reflected it over the y-axis, and that would end up being right there. Okay, that's all we have, and that's all for this session.